Hi everyone. In this final video on the Data Munging's notebook, we'll be discussing this problem again from the perspective of using Pandas. Since we've been working with tabular data throughout this notebook, it's very natural to complete this problem, or this project, this kind of like little project our case study we've been looking at in Pandas. And I want to reiterate again that the reason that we pose challenges to you like the PW mini project or the beginning of this notebook without Pandas is because frequently at least some portion of your data processing will take place outside of Pandas because the data that you encounter first may be totally unstructured or may not easily fit into a tabular format. But let's revisit kind of the analysis we did now using just Pandas. Once again, we read in the Fortune 500 data using Pandas read HTML. And we can use some of those functions that we created earlier to process the data in some of these columns. So for instance, we can convert the string revenue data using our convert revenue function. And we'll just apply that function to the revenue column. And we'll store the result in a new column called rev. And we can likewise create a new column with the number of employees by applying the kind of transformation we did earlier, where we looked up in the dictionary data the employee count for each company by name. So we use almost exactly the same code we did before, but now we're applying it to a column of the data frame. And then to compute the revenue per employee, we simply divide the one column, the revenue column, by the employee count column. And by sorting the data frame by the revenue per employee, we see, again, what we noticed before, that these petroleum companies sit at the top in terms of revenue per employee, followed by automobile companies, and then generally, kind of a mix of companies from other industries. To compute the market share, again, we'll read in those tables from the automotive industry page. To compute the total production, we can take the DF totals data frame, and we can simply sort by year. In fact, it is already sorted by year, but just in case, we'll sort the values by year. And then we can take the very last year, the most recent year. And we'll take, out of that row, we will take the production column. And that gives us this 97 million vehicles. And then to compute the market share of each manufacturer, we simply take the vehicles column of DF by man, right? That's DF by manufacturer. Now remember, this is a column of strings, and we found that we needed to convert those strings. And in particular, this Volkswagen Group string was a bit of a problem compared to the others because it contained commas plus this 40 in brackets, which if we look at the page corresponds with a citation. So we want to get rid of that. Of course, what we did before was we could just apply our convert production function to each string. And then we'll cast that column as a float and divide by the total production. In fact, I don't think we even need this casting here because this function already contains the casting as an integer within it. So once we've computed that share for each manufacturer, we set our index to the group column. That's this company name. So these company names become the index, which is going to allow us to pick out by name. We can pick out any rows we want. So there's our market share for Toyota and Volkswagen. Likewise, for the oil companies, we again read in the revenue table from the Wikipedia page. We strip out those asterisks just as we did before, because these revenues are strings as well. So we'll strip out those asterisks and convert the strings to floats. And the total is just going to be the sum of the revenue. And so we've put the cleaned revenue, the cleaned and converted revenue into this new column. We take a sum of that column, and that gives us the total revenue for the petroleum companies, $5.5 trillion. And then the market share is simply this revenue column divided by that total. So here are the market shares. And again, we notice out of our for petroleum companies listed here, not all of them are present. Sinopec Group is missing. Here we just have Chinopec. So this is a little bit different from before. Earlier, the mismatch we had was China National Petroleum versus China National Petroleum Company. If you are paying close attention, you may have noticed that there's a little bit of inconsistency in which versions of the Wikipedia pages we're using, and I hadn't caught quite all the discrepancies between the two examples. But nonetheless, again, we can do our fuzzy matching on our names. So we compute our split up names into words, just as we did before. For every company in the company column. Oh, right. Whoops. Okay, so I need to re-execute this. There we go. So I changed this to the Chinopec group. I reran the previous elements of our analysis. And there we go. So we matched that mismatch between China National Petroleum and China National Petroleum Corporation. And if we concatenate those two market share data frames, again, we get that view of automobile industries compared to petroleum companies. And we, again, notice the same kind of observations I mentioned before. Now, the data frame approach is definitely much nicer when we're working with tabular data. But keep in mind, a lot of what we made use of, like our fuzzy matching and our revenue and production conversions, were functions that we had developed previously. And if we had to walk through those for the Pandas example again, it would have still been a little bit cumbersome. But the apply kind of pattern for Pandas is really powerful, really nice, and great for data munging. It lets us organize a lot of functions that respond to patterns in how the data may deviate from particular standards we want to enforce. So we define functions to enforce those standards, and then we can just apply them to fields of our data frame. We don't need to write out any iteration or comprehensions to apply those. So that's going to wrap up our lectures on data munging. Next week, we will have lectures on SQL and object relation mapping, which will conceptually be pretty similar to the work we've done with Pandas.